welcome back to Algebra 2. Today's lesson is 9.7, which is frequency and period. We've talked a little bit about period so far. Period is how long it takes the sine or the cosine curve to make one complete cycle. All right, so usually if there's no number in front of the x, the period is 2 pi. So it takes between 0 and 2 pi in order to make one complete cycle. All right, and I'm really hoping that these are getting a little bit easier for you. You're remembering that sine begins at 0, ends at 0, in the middle is at 0, and cosine starts at 1, ends at 1, and in the middle is at -1, and then between all of those three, it'll be hitting its zeros. So I have using your calculator sketch the graph. You're at home, you don't have your calculator, and honestly, I'm not even sure you would be able to do this with the use of your calculator, although I told you how to zoom trig, and that will help you. All right, so if by chance we were able to use our calculator, so I can help you a little bit about what this is going to look like. There's no plus c on this, so what we're looking at is on the grid below is this function, so that's in the black, and what they want us to do, let's pick a different color, and let's do this one now in purple. All right, so what this is saying is that when x is either 0, pi, or 2 pi, we're going to double it. All right, so in other words, when we're looking at cosine of pi, we're really looking at cosine of 2 pi. So what this is going to look like, and again, if you could do this in your calculator, it would be easier, but what's going to happen here is between 0 and pi, we're going to get one complete cycle. So what we're going to do is we're going to shrink this. So we're going to shrink between 0 and 2 pi. So I don't want you to think about what's going on to the left of our y-axis. I'd like you to think about just what's happening to what's happening on the right side. So what's happening here is that between 0 and pi, we're going to have one complete cycle. So because this is a 3 and this is a 3, we're going to start in the same spot. We're going to start at 3, but instead of ending at 3 at 2 pi, we're going to end at 3 at pi. And then halfway between, we're going to be at -3 down here. And then in between these, we're going to hit the zeros. So we're going to have one complete cycle between 0 and pi. So that means that we're going to have two complete cycles between 0 and 2 pi. In between, we're going to hit zeros. So this one is going to look like this. And again, I'm going to show you an easier way to do this, an easier way to recognize this once we get a little bit further into the lesson. Okay, so let's just follow this around. So we are still in purple, that's good. So that means that between here and pi, we're going to be a complete. In between, we're going to be down here. In the middle, we're going to be at zeros. So even I have to talk this out to myself once in a while. So again, we're going to be here and here. In between, we're going to be down here. In between those, we're going to be at zeros. So this is what that looks like. So y equals 3 cos 2x on the same set of axes, which we just did. All right, so now how many full cycles or periods of this function will fit between 2 pi radians? So the one thing I'm going to do here is I'm going to give it a quick label, because whenever we put more than one function on a set of axes, you should always label it. So how many full cycles or periods of this function will now fit within 2 pi radians? And the answer is 2. We discussed that we have 2 complete cycles, meaning here is 1 cycle, and here's 2 cycles. All right, 2 complete cycles. So using your calculator, sketch it. Well, we talked about that already, and we did that already, kind of doing things out of order a little bit. Now it wants us to sketch a new function. It wants us to sketch 3 cosine 1/2 of x. So when we take a look at this one, let's change our color again. How about we use green, and we'll do this one in green. And what this is saying is between 0 and 2 pi, we're going to have a half of a cycle. So here we had 2 cycles between 0 and 2 pi. Here I'm going to have a half of a cycle between 0 and 2 pi. All right, so half a cycle, again, we're still talking about cosine here. So cosine starts at 1, but now it starts at 3. So it starts at 3. It ends at 3, but remember, we're only doing half of this. So half of this means it's going to end at, I'm sorry, in the middle, it's going to be at -3, and the middle of that will be the 0. So here is half of a cosine curve. And then we're just going to mimic that over to the other side. -3, in the middle is at 0. And again, we're going to make sure that we're not v-ing this too much. You want to make sure it's a nice curve. The left definitely looks better than the right. So this is y equals 1/2. I'm sorry, nope. We're not changing the amplitude at all here. This is y equals cosine 1/2 x. So how many full cycles or periods of this function now fit within 2 pi radians? I basically just answered that question already, and half of it does. So there are the two functions that we're supposed to be graphing, and I think they look pretty great and they're pretty straightforward. All right, so today we're going to talk about, it's not a horizontal shift, it's just a stretching or a compressing of the cosine and the sine functions in this situation. I just want to make sure that I'm still recording, and I am, which is a good thing. All right, so the period p of a sinusoidal function is an extremely important concept. It is defined as the minimum horizontal shift needed for the function to repeat its fundamental pattern. All right, so the period for the basic sinusoidal graphs is 2 pi. Clearly, from our first exercise, the period of the function depends on the coefficient b in the general equation. So we've talked about a before, we've talked about c before. Now we're finally introducing b, which is the number that sits in front of the x, or the theta, or the alpha, or whatever we happen to be using to represent the independent variable. All right, so now consider the graphs from exercise number 1. For each of the following, state the frequency and the period. So the frequency, we just talked about it, b in this case is equal to 1. And this is what we talked about, that it would be 2 pi. The frequency for the second one was 2, because b is 2. And the period here was a complete curve between 0 and pi. And the next one was b was equal to 1/2, and the period was equal to 4 pi, because we only showed half of it between 0 and 2 pi, which means between 0 and 4 pi, we would get an entire cosine curve. So as you can see, from exercise 2, the frequency and the period are inversely related. That is, as one increases, the other decreases, and vice versa. So examine the results from exercise 2 and what is true about the product of P and B. Can you think about what the relationship is between the two of them? Well, hopefully you're recognizing that the period is equal to 2 pi divided by the frequency. Or we can say 2 pi divided by whatever b was. Now remember, when we look at exercise 4, the amplitude, which is the A, the number in the front, has nothing to do with having to do the shifts of the period. Okay? So when you take a look at A, y equals 6 sine 4x, we're really just looking at this 4 here. So we're going to realize that my period here is going to be whatever 2 pi divided by 4 is. So this one is going to be pi over 2, which means I'm going to have a full sine curve between 0 and pi over 2. And I'm going to show you an easy way to graph these in just a minute. All right, so don't flip out too much. So this one looks a little complicated, but don't let it bother you too much. It's going to be 2 pi divided by pi over 3. And if you remember back from 7th grade, state change flip, this is the same thing as 2 pi times 3 over pi. So we cancel out the pi's, and this becomes is equal to 6. In case you didn't get that. Cancel out the pi's. And we get the same thing now with this one. This one is going to be 2 pi divided by 2 over 3. Again, you can do this in your calculator, although I wouldn't leave the pi. Leave the pi out of it, do 2 divided by 2 over 3. Or you can do 2 pi times 3 over 2. Put this over 1. The x's cancel. I'm sorry, the 2's cancel. And I'm left with pi over 3. So we get a complete curve between yeah, I'm a little bit crazy here. Thank you for recognizing that, because I'm pretty sure you realized that, because I didn't do my math right. So the 2's cancel out, and I simply get 3 pi. Okay, so this one was 6. This one was pi over 2. All right, now that's really helpful, because if you know what the period is, it's easier to graph it. All right, because we can create, so if you take a look at exercise 5, you'll notice how in exercise 5, I did not put in x values. I didn't do the usual 0, pi over 2, pi, 3 pi over 2, 2 pi, because when you're doing a shift like this, like you want to be able to do the actual curve and then put in the y value, I'm sorry, the x values later. Hold on. All right, sorry about that. Before I go on to exercise 5, I just want to do a simpler one. It's not in your book, so I just want you to watch. Okay, so I just took a new graph and I put it here, and let's just take a look at a very simple example. How about y equals sine 2x? Something like this. All right, because we know what a sine curve looks like, not even considering what that 2x looks like, because we know if we consider what this looks like, we know sine starts at 0, ends at 0, and in the middle is at 0. And let's just make it a little bit easier. We'll make this a little bit bigger. All right, so I know that sine increases, then decreases, so the sine curve looks something like this. And if I follow it around, it looks something like this. So I went to 2, but I just changed my units on my y-axis just to make it a little bit bigger. Just making sure I'm recording. All right, so that's what this looks like. Now, the only difference is normally here, we would be between, in y equals sine x, this would be 0, this would be pi, and this would be 2 pi. All right, so normally that's what it would look like. But because we have y is equal to sine 2x, I know that my period is going to be 2 pi divided by 2, which is pi, which means I'm going to have one complete cycle, not between 0 and 2 pi, but between 0 and pi. So I know between 0 and pi, I'm going to have my full circle. And actually, I can keep the 0 here if you wanted to, between 0 and pi. So that means now you can leave it like that. You're perfectly fine. All right. So you can put negative pi over here and you're done. But if you wanted to add in halfway between 0 and pi is pi over 2 is 90 degrees. And over here would be negative pi over 2. So you can add that. And this is how we draw graphs without making ourselves too crazy. We know what the sine graph looks like. We know what the cosine graph looks like. So let's just draw that and then change on the y's. All right, the announcements of this assembly are making me a little crazy. But anyway, so taking a look at that, now let's look at a more complicated one down here at exercise 5. So this one is going to be y equals 2 sine 4x plus 2. Get rid of this. So in this case, knowing what your information is kind of helpful. Your amplitude is your a, because I'm going to remind you. It's y equals a sine bx plus c. So my amplitude is my a. So that equals 2. Remember, that will always be positive. Even if it's a negative 2, it's going to be positive because amplitude is a distance. All right? Then your frequency is your b. So my b frequency in this case is 4. And my period is going to be whatever 2 pi is divided by 4, which is pi over 2. Now my midline is my c. I didn't put this is my b. My midline is my c, which is y equals 2. So let's put that in here. And that's where I start. So what we're going to do now is we're going to create our curve the same way we created it before, pretending we're going between 0 and 2 pi. So if we consider our midline, and now we consider our sine curve, it's a positive sine curve, so I know that my sine curve starts at 0, or at the midline is 0, ends at 0, in the middle is at 0, right? And the same thing goes for my negatives. I always start at 0 and move to the right, and then fill in to the left. So I know that my amplitude is positive 2. I'm not even considering my frequency yet. I have my midline considered. So the first thing as I thought about was my midline, and I drew that in. The next thing I determined was my amplitude and whether or not it's positive or negative in front of it. And then the next thing I'm going to consider is, and I consider drawing it. So I know my amplitude is 2, so it means that instead of going to 1, I'm going to go 2 over my midline, 2 below my midline, so my sine curve looks like this. And again, just using a little bit of common sense, I'm going to follow it to the left. So this is what it looks like. Now, we did this not even considering what the frequency is and what the period is. So in this case, I know my period is pi over 2, which means that my full cycle is going to be pi over 2. I know this is 0. That's pi over 2. All right, they're killing me. All right, now if you want to do halfway between pi over 2 and 0, it is pi over 4. So you can put in pi over 4 here, negative pi over 4 here, and negative pi over 2 over here. So the last thing now we did was we considered the period. So it's a little bit easier to do it this way. I mean, again, my advice to you is now, if you want to use your calculator and you have one, you can put this in your calculator and make sure that this appears the same as your calculator. But I'm going to remind you that pi over 2, pi is 3.14, so it's going to be half of that of pi over 2 and a quarter of that of pi over 4. It gives you the numbers. Okay, so Miss Gilroy. All right, so that's the end, exercise 5. My advice to you on these is please make sure that the independent practice for 9.5 through 9.7 have been done in their entirety. It's really the best way to make sure that you understand what you're doing and you have enough time to practice them. All right, so if you've been instructed to continue on with the independent practice, please get that done. Use everything you learned today and previously, and I promise you, this is not that hard. Don't overthink it. All right, come and see me if you're having issues with it. Some one-on-one time is always helpful. All right, so until next time, always make good choices.